Hello, everyone. Thanks for coming. My name's John. I work for a company called Progress. Some of you may know us as Telerik, and hopefully you're using our software development tools. Telerik is a company that has been building UI control sets for .NET and .NET platforms for well over a decade. We have 1.9 million developers using our tool set. If you need to reach me, you can find me on Twitter. So check it out there. Incidentally, earlier today, we actually had quite a nice announcement regarding our toolset for UWP. Recently, we were accepted into the .NET Foundation. And to celebrate this, we've got a little contest going on here where you can have a chance to win one of these cool-looking T-shirts. So Telerik is in the rich tradition of doing really cool T-shirts. So feel free to check that out up on our blogs at telerik.com. If you haven't used these controls, they're great. They're open source. They're available up on GitHub. There's about 20 or so controls you can use for UWP development. But we are not here to talk about that. We are here to talk about NativeScript. So to kind of help you along, I'm going to spend a little bit of time in slides, but most of the time in demos and code. So first of all, what is NativeScript? So NativeScript is basically a cross-platform native iOS and Android app platform. It's for building those types of apps. You can use a combination of JavaScript or TypeScript and Angular if you wish. And by utilizing those, you can actually build native UI with all the richness and performance that comes along with it. So really, for NativeScript itself, our intent was to build this open source framework that would allow you to leverage your existing skills around web development. So you can style native elements using a subset of CSS. You can construct your UI using an XML dialect that we have. And so if you're any proficient in the web space, you can go ahead and use NativeScript quite nicely. It's a combination of tools, it's a combination of components, and includes a whole bunch of things, as you'll see in a sec. If you want to find out more, you can start by visiting nativescript.org, and we walk you through all the steps necessary to get everything up and running on your machine, as well as a whole bunch of docs about getting started with building apps, etc. There's a very large development community surrounding NativeScript at the moment. A lot of them are building plugins, etc., and we'll talk about that as we go through this. To get started, you'll download a CLI typically and plug away. I'll show you how that actually works. So let's jump over to our terminal window. And to get started, you'll just install the NativeScript CLI via npm. So opening up a new terminal, you'll just say npm install, and then NativeScript is the CLI that we have for building out all this stuff. The CLI itself is alias to TNS, which stands for Telerik NativeScript. And it has a bunch of commands for creating projects, for deploying to devices, including emulators, for publishing to app stores, and a whole bunch of other things as well. So lots of great stuff there. Let's take a look at an example of what NativeScript looks like on a device. So this is a NativeScript app that I have on my iPhone here. And it's a little janky because of the throughput to the display, but it's smooth 60 frames per second scrolling on the device itself. So don't interpret that little jankiness as what it actually looks like. The performance is actually quite nice. So inside of NativeScript, we have a whole bunch of characteristics and aspects for creating rich UI and also interacting with the underlying subsystem. So we have things like layout, for displaying content in a variety of ways. We have integrated bars and bar charts and graphs and things like that with animation support. We have very scrolling through list views. Now, on my screen it looks good, but up there it looks terrible. So it's actually not dropping any frames. So rest assured it looks really good with including layouts as well. These layouts can be adapted using CSS, so you can certainly style them. And there's a whole bunch of conventions as well that you can incorporate for NativeScript itself to target specific platforms. And I'll talk about that as we look at the code. So things like this, you may wonder, like, what's the big deal and why is this important? The reality is that when you're building applications for mobile today, you have a lot of choice, and some of them come with some caveats. And in this example here, what we're targeting are native UI constructs. So these are elements from UI kit that are being targeted. If I was on Android or I was running through the simulator there, I'd have obviously the Java classes that are available through the SDK that I would be targeting on the native device. That's different than what you may be used to with other platforms that target PhoneGap or host containers that are Chromeless browsers. And the idea there is with a hybrid environment, you're running inside a browser, and there are some limitations to that. This is running right on the metal. This is JIT compiled JavaScript running against native objects on the platform. So I'm just going to jump around here just for a second. So just coming back here, we've had a bit of a long timeline with NativeScript itself. So we've been developing NativeScript for quite a while now, and we're currently just past the adoption ramp up, and we're into global dominance now in 2017. So that's our intent. That's part of the actual project guidelines for that, is to have world domination across the board. On that note that I spoke earlier about hybrid, this was dating back a few years, but basically the idea was that I wanted to leverage web and bridge that gap that exists between what's available through the browser and what's available on the device. And so with hybrid, there was this sort of reality that came about, which is with the browsers that were coupled for hosting your apps on mobile platforms, they were somewhat limited in terms of performance. And so there was a series of compromises you would ultimately have to go through when targeting hybrid. So moving forward, what you ultimately want is the best of being able to target web-like technologies and coupling that with the best experience or performance. And that's really where NativeScript tries to come into play. And so with NativeScript, what we're trying to do is we're trying to target that fast-to-market, leverage existing skills experience with super fast performance on the device itself. Now, the way that it does that is through a number of different means. And just to clarify some of the capabilities here of the platform, the way we do this is sort of complicated, but it's sort of understandable if you have any experience with other platforms on Java or .NET in terms of platform invocation. So the idea here is that we have on the bottom, which is where our application code resides, the JavaScript or assets running within the app package itself, which will make calls into the native APIs, the underlying subsystem. The way this is done is through NativeScript itself, which is actually responsible for marshaling and dispatching calls and types across the wire to the native APIs. So we do all the heavy lifting of making sure that types are converted correctly or coerced correctly. We do all the necessary metadata exchange in terms of the API spec and dispatching the call both into and out of the native API itself. The way this ultimately looks to you is it's somewhat transparent, but what it allows you to do is basically make invocations such as this. So this is an example of an application running on Android written in NativeScript and utilizing the time class. So here I'll instantiate a new instance of that, and then I'll set its values using the set method, and then output that to the console. Ultimately, it really doesn't matter what sort of code example you look at here, but this is ultimately using that time class underneath the covers. Same can be said for something like iOS. So on iOS, you can go ahead and instantiate UI kit elements or any other elements for that matter. And it's not just UI, it can be other subsystems of iOS or Android itself. So what we do is we expose these types available to you, either in JavaScript or through a type definition file if you're targeting TypeScript, and you can simply just invoke the calls directly. So here we're instantiating a UI alert view, setting some properties, and calling the show method to display it. Now you may notice that these actually map almost one-to-one to the existing properties within the docs or exposed on the metadata. That's intentional. So if you're coming from a platform where you're doing a lot of Objective-C and you've been targeting iOS for a long time, NativeScript itself will feel very natural. The same thing goes if you're an Android developer and you've been targeting the SDKs there and getting used to the APIs. At the end of the day, these two code examples ultimately run on the JVMs that are exposed on both iOS and Android. So in the case of Android, we're running on V8. In the case of iOS, we're running on JavaScript Core. And by exposing that, we can go ahead and make very, very rich applications, but still leverage the capabilities of the language that we wish to target, i.e. JavaScript or TypeScript. It also should be noted that we can also target Angular, which is another first-class citizen for us as well. So taking a look at this a little bit more deeply, this is on a very simple API by API basis. NativeScript itself comes with a series of modules. So NativeScript itself, there's the runtime, there's all the stuff that happens there. But to help the development platform along, there's a series of modules that you can take advantage of. And what these modules are a series of basically like plugins that you can use and simply require in to take advantage of. So if you want to take advantage of, for example, the file system, there's a file system component that you can take advantage of. And there's other ones as well. The reason why this is nice is because from your perspective, i.e. the developer, you don't have to worry about the individual aspects of both Android or iOS. You simply utilize the module, plug away, and then it will do the necessary heavy lifting for you. So in this example here, we're using the file module, which simply you just require in, and then instantiate a new file object with a path specified. Underneath the covers on Android, this will invoke java.io APIs. And on iOS, this will use NS File Manager for doing the right things. So ultimately, at the end of the day, these modules are there to abstract away the differences between platforms. So from a simplistic perspective, this is how it kind of hangs together. You have on the top your application code that either invokes modules or will just simply go against the individual APIs via the runtime, and then those will target the independent platforms directly. As I said before, there are conventions we have within the application logic itself that allow you to specify things like, hey, if I'm running on iOS, call this. If I'm running on Android, call that. We also have file-based conventions as well. So in a second, you'll see this where on an individual file-by-file basis, you can specify whether or not you want to include this file on an iOS build or include that file on an Android-based build. Putting this all together, so we're fans of XAML at Progress because of our rich history with building UI for WPF, et cetera. And so we've defined an XML dialect that you can use. For those of you who are used to React Native, this is sort of akin to JSX, where you can actually specify a UI, and then those will map to individual elements that are native constructs on the individual platforms. So in this example, I have a page here, and as you look at NativeScript, basically, pages are how we hang screens together. And that has an event called loaded that I can go ahead and specify an export for. And then inside here, I have a label that I'm binding to a property, which I'm exporting as well. I can then underpin that with JavaScript. So here, I'm going to go ahead and define an event handler for the load event. And then on there, I can go ahead and set properties against what's called an observable, which allows you to do two-way data binding. This is a construct through the observable module that we provide in NativeScript. And that can also apply to collections as well. And then you set what's called a binding context. If you have any use or exposure to environments that expose this sort of pattern, binding context is just this thing that exists that you can reach up to and set properties on. And if I want, I can go ahead and style using CSS as well. So an example of this might be something like a to-do app where you're specifying properties. In the bottom here, you can see we have a segmented bar as an example. So I'll jump over here to a different environment and show you how this hangs together. So I'm going to jump into my command line, and I'm going to go ahead and create a new project. So I'll say tns create, and then I can call this NDC Sydney 1. What this will do is it will specify for me a default template and output to the file system the project associated with that. So if I go to NDC Sydney now, there are a variety of templates I can also use, but we'll see those in a second. I get a structure that looks like this. So open this up in code. So over here on the left, you can see I have my various folders here for my node modules. Platforms are the individual platforms I'm targeting. Package.json obviously allows me to specify my package parameters. If we take a look at app, you'll notice here we have pretty simple structure. We have a JavaScript set of JavaScript files, an XML file, and a CSS file for my overall app. So if I take a look, for example, at my app itself, this is basically how life begins within NativeScript itself. So we create an instance of the application object called .start, pointing it to the main page as our starting point for the application. This is the markup that was generated by the NativeScript CLI. So you can see here on their page here we have an action bar, and that action bar has a title as well as a class which maps to a CSS rule. And then underneath here we have the various layouts that I showed you earlier. So inside this stack layout we have 3 elements, a label, a button, and a label. And those are styled using the CSS file that you have here. So I can define all kinds of various rules if I wanted to on the native elements itself. I could also style these in a variety of different ways as well. If I wanted to, I could specify things like view models. And so underpinning that main page.js, I have this view model page that allows me to specify the number of times I've tapped on the screen. It's pretty simple stuff. So if I want to go ahead and now use this and deploy it to an environment, so I have 2 environments here. I have Android and I have iOS. I also have a device that's paired here. I can choose any one of these environments and target them independently. So if I want to, I can go ahead and issue a build, and I'll build for iOS. This will leverage the Xcode CLI that is installed on your machine. One of the things that I wish we could do better, but it's just the reality of the situation, is that if you're going to target iOS, you have a variety of dependencies that you need to target on your machine itself. If you are running on Windows or a Linux distro, you will have to utilize a cloud-based build system. So we support that through another tool, which I'll show you. But ultimately, if you're wanting to build IPA files, which are those executable files that iOS uses, you're going to have to use a Mac or cloud-based build. Fortunately, with Android, you can do it on either system. So it's gone ahead and built. Now, if we take a look at the structure here, you'll notice that inside my platforms folder, I now have an iOS directory. And inside there, I have an Xcode project. I have also a variety of assets as well, including the individual build itself. So I can go ahead and grab those if I wanted to and look at them in Xcode. But ultimately, that's what we're doing. We're generating these builds underneath the covers. If I wanted to go now run this on the emulator and go ahead and say tns run iOS -- emulator. And I can also get a device listing as well. So if I go ahead and say, say if I have a bunch of different environments, I can say tns device list. There's a variety of commands you can go ahead and check out. But you can target individual devices, including emulators, connected devices, etc., simply via their GUID. And so you'll get those listed here. So you can see I have 2 emulators and 1 device connected. Jumping back to here, you can see my application is now running. I'm getting console output to the screen. If I jump over to my simulator here, there's my application. These are native elements. So that is a native action bar. There's a native element for the labels and also for the button. So if I were to inspect this within Xcode, for example, they would actually show up as UIKit elements. You can see it has responsiveness here, targeting the view model. Nothing major going on here, nothing magical. The difference is that in terms of how this differs from, say, like PhoneGap or other environments, there's no web view here. This is all native, so it's running native on the device. It's also JIT compiled, so the performance is going to be really good. Now that's all in good. If I want to, I could also simply switch this up. I can say now run Android, simply by saying tns run Android -- emulator. And what this will do is obviously search my list and install this on the simulator that's here. We integrate with a variety of build environments as well. If you're using, for example, CocoaPods for targeting iOS, we integrate with that. We can integrate with shared frameworks and libraries, native frameworks and libraries, both on Android and iOS as well. So you don't have to port all your existing investment. You can take your existing libraries that you've already built for both iOS and Android and incorporate them as part of your build. We are using Gradle-based builds for Android, and this is evidently something that we support here. I was brave enough to do this. I downloaded the image for Android O, which is the latest version of Android 8, and it seems to work just fine. So it's one of the benefits of being able to utilize systems like this that just simply dispatch, the fact that you can actually just call new APIs as they're available and utilize them accordingly. So there's my application there running on Android, and again, the exact same experience. So pretty simple stuff. Along the way, there's a whole bunch of various UI aspects you can incorporate. So if I wanted to, I could go ahead and take a look at those. But we ship a whole bunch of modules as part of NativeScript here. So This is our API reference. You can see we have a variety of modules that are included here for things like file system access, data, et cetera. Where you're going to see most of people focus their time is on the UI side. So you can see we have UI elements for a whole variety of things, including the basics like buttons and date pickers and things like that, and also things like labels and layout and all sorts of stuff. So these are exposed to you via NativeScript. But that being said, there's always going to be something that people want to leverage in terms of the platforms themselves. So if there's, like, say, for example, SQLite as a backend database, you want to leverage that, you can go ahead and do that through a plugin. So there's a variety of plugins that are published up on NPM. Currently, there's 631 packages available there for NativeScript. And if you scroll through here, some of these we've written, others have written them. So here's a plugin, for example, for Firebase. So if you want to integrate with Firebase as a backend, you can go ahead and do that. Simply pull down the plugin and utilize it accordingly. The way you do this is actually pretty simple. You can simply just go up to the CLI itself. So I'll go ahead and stop this. And you say TNS plugin add, and then the name of the actual plugin itself. Oops. And then our CLI will go about and pull that down, install it as part of your node modules, and then make it available to you if you wanted to. There you go. So I can go ahead now and look at the docs and say, okay, how do I use this sucker? All right, so I go on iOS, for example, and set a property key. I can call firebase.init, et cetera, and that's how it works. Make sense so far? Okay. Plugins are pretty simple. There's just a ton of them out there. Some are for back-end underlying plumbing stuff. Some are pretty front-end forward stuff, like UI specific. So here's one that allows you to specify a toast if you want for feedback, if you will. So I've written one here for sound. So you want to integrate with the sound aspects of both iOS and Android. It's pretty simple here. This is one that I wrote called NativeScript Sound. And simply adding the plugin's easy, and then you just simply require it, and then create sounds, and then call play and stop, etc. So pretty simple stuff. All right. There are other aspects to this as well. So we have a variety of rich capabilities built in the CLI. So I can go ahead and say, for example, TNS debug iOS if I wanted to. What this allows me to do is I can go ahead and integrate with Chrome DevTools if I wanted to. So this allows me to get live debugging. We have integration also with VS Code. So you can do live debugging with breakpoints and things like that in VS Code if you want it against emulators or devices running on your platform. And you can do a number of interesting things here. So here it's going downloading some pods and installing them because I had this dependency for the Firebase plugin. So we use CocoaPods as well. Eddie, who wrote this, uses CocoaPods as the underlying plumbing for this. And then it goes through its process and then allows you to target it accordingly. You'll notice here that it's actually prompting you for a variety of settings. So I'm a member of more than one development team for my Apple developer. So you have to specify things like that. You have to do all the normal things you normally would if you're wanting to target iOS, like, for example, create a developer profile, download a certificate, a provision for your device as well. So a lot of those things you still have to do, unfortunately. That's just the nature of mobile development. But yeah, it works out pretty well, I find. And the fact that you can target languages you already know and love without having to learn something like Swift or Objective-C or even Java is pretty nice. Now you may wonder, this is taking a while to build. Do you support things like incremental builds and things like that? Yes, the answer is yes. And we also support sort of like a hot reload capability through a feature we have called Live Sync. So with Live Sync, you can touch files. It will propagate changes directly to the device inline without having to rebuild and reissue the actual environment. So I've got this on my phone here. So you can see it's on my phone. Just got my phone here. I'm just tapping on it. So what I can do now is if I wanted to, I could go ahead and debug this using Chrome. And I can go ahead and fire up a new tab of Chrome and connect directly to the environment here and inspect elements and do all that great stuff if I wanted to. The reason why we do this, obviously, is because it turns out to be a pretty nice capability for folks being able to inspect values, such as element values, CSS properties, et cetera, and then modify them to tweak them to see how they change accordingly. By default, if you don't specify that --Chrome, we target Safari. At the moment, though, this is only running on Android. I should have remembered that. This is coming soon for iOS. This is currently support on Android. So let me just kill this one. And I'll say Android -- Chrome. So this uses WebSockets through the Chrome protocol and allows you to debug this pretty easily. So this is going to go ahead and issue this against my emulator here. And I'll just go ahead and put this one down. There we go. While this is building, I'll just show you some examples, some other examples of things that you can do in NativeScript through my phone. There we go. Perfect. It's always fun when you're doing a live demo on your phone, your actual phone, because I'm sure my wife will text me at some point. So we'll see what happens. There's some apps here that I have that showcase what's on NativeScript itself. There's a variety of different things that you can do with NativeScript as part of the experience. I've got an example here, SDK build, which is, nope, not you. Where are you? I thought I had them on my phone. I guess I don't. No, that's from, yeah, it's Brostein's Brothers. I don't have it on my phone. My apologies. Oh, I guess we got a build failure. So I've got this build failure here. I'm not sure why I'm getting this, so I'll have to take a look at that. Apologies for that. That's just for the development experience. A tool we just recently added to our arsenal. So you've got all the CLI stuff that you've seen already. If you're at all interested in building this stuff, that's one great way to go. We've had that out for a while. This is another tool that we've just recently put out there called NativeScript Sidekick. So Sidekick is sort of like the Visual Studio-like experience for creating out these templates. This is another experience that we built out. This all targets the CLI under the covers, but gives you some rich capabilities as part of this. So, for example, if I go ahead and create a new application here, you can see that this stuff is exposed via the CLI. We just put a pretty interface on it. So here I can go ahead and create a new application name, and I'll go ahead and call this NDC Sydney 2, for example. I'll go ahead and specify a different app ID because I have a different certificate and provisioning profile for my device. And then here I can specify the project type. So here I can say I want to create this using just plain old JavaScript, or I want to use TypeScript, or I want to use a combination of Angular and TypeScript. So we support all of those. And these are just templates that we have built out of the box. So here I can create one that's just a blank template. I can use one that has an integrated drawer if I wanted to, that utilizes a component we have, tab navigation, or even a master detail type application. So I'll go ahead and create this one. And in a second, we'll just take a look at the code that's actually generated for this. This is a pretty simple example where under the covers, we're utilizing Firebase and Angular for creating this sort of environment. So this is just a listing of cars that you might see at a rental dealership. And the way it's hung together actually makes pretty good sense. That's part of the reason why I like this. You don't have two code bases. You don't have to worry about differences in those different environments. Simply just target one and away you go. So once that's built, you have this display here which allows you to tweak various settings if I wanted to. So I can change its description, its identifier, etc. I can also specify specific aspects to each platform, so for iOS or for Android, as well as asset management. So this is for things like start screens, logos, etc. These are bundled in as part of the package that we generate for you. So these are sort of the splash screens that are shown when it's launched. And then any plugins that you may want to incorporate. That plugin integration through the CLI I showed you earlier, this is exposed here. So these are the ones that come out of the box based off the template. But there's a whole variety of plugins that you can use as well if you wanted to take a look. And this just simply goes up to NPM to take a look. So if I wanted to, I could say I want to incorporate Firebase as an example. And these are the ones that are up on NPM that you can incorporate. So I'm not going to go ahead and do that. What I'll go ahead and do is I can issue a new build. So I can choose the target platform I wish to build for as well as their configuration. I can also down here, if I wanted to, issue either a local build or a cloud build. So cloud builds, we have a bunch of Mac machines sitting up in the cloud. We take your assets, we build, serve you back down an IPA. Additionally, if you're targeting Android, for example, we'll send you down an APK. Just taking a look at that example, some people sometimes wonder about this. So here, if I go ahead and navigate to this location inside the Finder, so I'll go into Dev, TNS Projects, Sydney 1, actually Sydney 2, I'll go and just take a look at this. So here's my project that's been generated by Sidekick. You can see there's my app, and I've got my various files here. If I go ahead and now build this, so I'll go ahead and do an issue, a local build using iOS. This is the same sort of process that we have underneath the covers using the CLI. So we're utilizing the Xcode CLI. We're targeting iOS in this instance, and this will generate for me an Xcode project underneath the covers. So here, we'll take a look. I have a platforms directory. Soon I'll have an iOS directory. There we go. And then it's generating an Xcode project to build against. Now, ultimately, at the end of the day, we'll end up with an IPA file. And that IPA file is simply an app container for your assets. So it's gone ahead and issued that build. And take a look here. Where's our build? Sydney 2. So you can see our assets are as part of the project itself. And then if we take a look at the IPA itself, it will have this directory structure within it. Some people don't like that. Some people get nervous and they're like, well, I don't want my JavaScript file sources present in the application itself. How do I get around that? How do I mitigate that? We just wrote a blog post earlier that allows you to sort of obfuscate a bit of that through a partnership with JS Scrambler. So if you take a look at our blog, we just wrote about this this week, where JS Scrambler allows you basically to make it more difficult to reverse engineer your JavaScript that's present in your IPAs and APKs. So you can go ahead and check that out if you're interested at all, because ultimately this is what's generated as part of it. But what's spat out through JS Scrambler is something that's pretty opaque. So you can go ahead and take a look at that as well. So once that's built, we can then go ahead and utilize it. I'll just show you what this looks like here. I'll just go ahead and open up the shell. Great. So I'll go ahead and run this against iOS. And again, this is going to find a list of devices. It picks a default one, which is typically top of the list, and then it executes that. That's through the tool. Through the command line, it obviously gives you prompts. And again, this is utilizing data coming from Firebase and built on Angular. So the build succeeded. It's got the IPA in just a second here, and we'll deploy it to the target. It's always fun to watch this. We do support incremental builds, as I said earlier, so it does get faster. This is just because of the first time I've issued this. Yeah, apologies for the res as well. It's just, you get these emulators and simulators that are pretty small. So, all right, so we're targeted for the device. There we go. So we can go ahead and launch this now. Oops, there you go. This is actually on my device here. And again, this is pulling data from a backend, so depending upon your network, obviously sometimes it's going to be a bit slow for that. It's also issued that build for, obviously, iOS on the simulator as well. That did not like that. I think my network's gone down for Firebase. Nevertheless, I'll show you what the code looks like for this. It's actually reasonably easy to understand. Not you. So if we take a look at the code for this, this is again the one that's based off the template for Angular and TypeScript here. Our application is here. This .app stuff is where we basically, that's where life starts basically for our application, a lot of bootstrapping, etc. And then our application itself is a series of screens for things like cars and things like that. So we have a listing of cars here. It's described within our XML here. The reason why it's given this extension .html is because it's actually it's better for syntax highlighting for angle brackets and such in different IDEs, but it is an XML dialect, so you can say .xml if you wish. You'll notice here we have not only Angular event binding, but also property binding as well. So here we're utilizing those characteristics for our rad list view, which is a UI component that we have available for displaying elements in a very smooth scrolling UI control. We also have a template here defined that allows us to specify the individual layout for each individual car. So each individual car itself will leverage a series of labels, etc. And then we have a very series of stack layout elements on this page as well. You'll notice over here, as I said earlier, there's a set of conventions we can do. So you'll notice here that I have a variety of styles that I've specified for not only the component itself, but also for individual platforms. So if I wanted to, as part of my build process, specify individual platforms for various styles, I go ahead and do that. So anything that's prefixed with .android will get picked up in the Android build, .iOS, iOS build. And so I can specify any rules I only want for Android here. And same thing goes for iOS. I can also do the same for individual source files as well. So if I had an individual source file that I want to use for iOS, I can go ahead and do that. Same thing with Android. So just saying .android or .iOS. Here's our underlying list component for the cars themselves. You can see we're specifying our component. This is where our template lives for that source file that I showed you earlier. And then any styles that I wish to specify as a collection here, I can also do so as well. Again, this was built utilizing or targeting the Android template, so that's why that's there. I think the reason why this guy is not showing up is because my network connection is not working so well right now for Firebase, which is the underpinning for that. Yeah, it's dropping out. It's unfortunate. Cool. There's a variety of other characteristics as well that I can talk about, but yeah, if you're all interested in this sort of stuff, you can certainly target it very easily, either through the CLI or through Sidekick itself. Sidekick itself is pretty nice just in terms of giving that sort of visual display on top of this. So jumping back here. So we have a variety of applications that have been built on top of this. We've got some other things that you can do with this, which are kind of nice. Just going over some of the individual sort of things that you can do. Obviously, with all the dependencies, that can be tricky for making sure that your environment is set up well. You have to have a certain version of Gradle, certain version of CocoaPods, certain version of the JDKs and SDKs for each individual platform. A lot of this stuff can be problematic. So we have this doctor command inside the CLI that will simply inspect your environment and tell you whether or not everything is good to go. As I said before, everything is pretty easy to drive through the CLI itself, and running these on individual emulators and environments turns out to be a pretty simple thing to do. Just to kind of clarify some of the things that I mentioned earlier, I said loosely, just very quickly, that all these things are based on pages. That's really the first-class citizen of NativeScript applications themselves. But as you'll see, there's a variety of various UI elements and layout things that you can take advantage of. So mentioned briefly the layouts, but the widgets themselves are highly varied, and there's just a ton of them that you can target. That being said, if you want to target individual elements that are exposed through native API, you can use either a module or target them directly. So nothing prevents you from invoking direct APIs against either platform and utilizing them if you wish. And we support that through as part of the environment. Looking at that example I showed earlier, the to-do example, you can see how these individually map to various native elements. And if you're looking at how you space these out through layouts, these are done through our layout mechanism that we have available. There's a whole variety of things that you can also do with NativeScript itself for things like event handling and property binding and a whole bunch of other characteristics, but I won't worry. You don't have to worry about that for right now. If you're looking at doing anything around data binding, it turns out to be pretty simple. I showed you this example earlier where you can set a variety of things against the binding context, but we have this notion of what's called an observable, which you can take advantage of if you wish. So simply by targeting the observable itself and setting properties against it, you can be notified of property changes when they occur against that object. And you can go and do some really complex binding patterns here if you wish. So you can set to various collections if you want and bind accordingly. And that allows your UI to obviously update as changes occur. There's a variety of expressions we also support as part of the data binding itself. So for a variety of operators that you wish to convert against these elements itself. And styling turns out to be pretty easy as well. So through CSS, you can certainly style these properties quite easily. As I mentioned earlier, by convention, this is how we go ahead and style them. So your view name will actually map up to the underlying view itself, and then you can say a platform if you wish. We do support a subset of CSS, so it's not the entire set specification. These are some of the supported properties. We've added some recently that we've been working on, like Flexbox as well for laying out objects. But it turns out to be pretty nice in terms of how you can style these things accordingly. NativeScript itself, as I said, is pretty rich. There's a very rich plugin ecosystem, as I said, and there's a whole variety of plugins you can use today. And that also includes integration with a variety of environments, such as Visual Studio Code. So there's a set of plugins you can write or utilize inside of Visual Studio Code for integrating with NativeScript apps running inline. As far as other things are concerned, our performance with NativeScript is pretty good. We recently wrote a blog post about performance for NativeScript itself for our 3.1 release. So we take a look at our blog here. We do try and publish all of our perf specs or our perf announcements around this. We wrote about this recently in our 3.1 release. So you can go and check out that blog post if you wish. The reason why part of this is oh, sorry, I'm still on the slides. I apologize. So recently we've been writing a little bit about our performance. In our latest release of NativeScript, we've added some capabilities to allow you to capture traces. So in your package.json file, you can specify that you want to specify a new profiling property, which is set the timeline. And when you do that, we will output not only to the console, but through tooling that is a plugin, timeline view that you can go ahead and inspect and take a look at the startup time for NativeScript apps as they run as part of the report. So as an example, we talk a little bit here about an application called Practice Buddy, and we show you basically how long it takes to load various aspects of the application itself and why things take as long as they may take in some cases. So there's lots of capabilities you can integrate there. So definitely worth checking out as part of that environment. So as I said before, NativeScript is completely open source. You can go ahead and check out the source up on GitHub through our repo, which is /NativeScript. Currently, we're just shy of 11,000 stars. And if you have any issues with that, we go ahead and accept issues there, as well as pull requests if you have any that you want to submit. We have a variety of extensions and also templates available through here. And if you're wanting to get writing your own plugins, we have a seed project here from Nathan Walker, where you can go ahead and get these things written up pretty quickly. So lots of tooling, lots of repos available there as part of that environment. If you're interested at all about NativeScript from an API or docs perspective, we're pretty full-featured here on our docs site. And if you're looking for showcases, we have a whole bunch of them up on our website here. So we have a variety of apps that have been built using NativeScript that you can also check out here that people have been really successful for. One notable thing is recently SAP chose NativeScript as their basis for building out their future applications for their app modular. So that's definitely something worth taking note of. So SAP seems to think it's pretty good. So we're happy about that. And yeah, got lots of stuff going on there. Any questions at all about NativeScript you might want to ask in terms of, yeah. Yeah. So the question is for people who are watching this on the video, in the Sidekick app, when you generate the template for the Angular-based project, how do you override the theme for the project? Because when you attempt to set it from light to dark, it doesn't take effect through Sidekick. Sidekick itself is very early. There's lots of properties and knobs and switches that are missing from it. So at the moment, that's not supported through the Sidekick tool itself. But that's something that certainly after the fact you can change as part of the project's source files if you wish. So, yeah. Any other questions before we wrap things up? No, it's a bit early, but that's all right. So, anyways, just check it out. It's at nativescript.org. Really appreciate your time. Thanks for listening. Cheers.